This is Mrs. O'Neill for Chapter 12, Section 3, Part 4, your practice problems. So in this video, again, you should have out your real periodic table, your ion chart periodic table, calculator. I'm going to give you some reminders before you start and then how you should proceed with the video. Also, 3 Sig Figs is always best. So I've always talked to you about 2 decimal places. I will tell you though, if you have numbers that are greater than 1, so if you have a whole number, I'm always using 2 decimal places. However, because of this mole ratio, sometimes you're going to get a number less than 1 for your moles of your substance that you want. And so then I usually say go to 3 decimal places. So again, because you're less than 1, the more numbers you have, a little bit better to work with. So then I usually go to 3 decimal places, and that would give us the 3 Sig Figs. So as a reminder, when we're trying to find limiting reactants, you're basically doing 2 stoichiometry problems, right? So you're starting at any quantity, using mole island to go to moles, and then using that new mole ratio step to get your substance A to B. There's where we're going to stop. We're going to pause, and we're going to compare those moles of our substance B, the substance that we want. So the smallest number of moles is going to be our substance that is our limiting reactant. So then we can finish the problem and again go to any one of these quantities using mole island, right? So we want to remember that that limiting reactant is going to limit us from how much of that product or that substance B we can make, right? Because we only have so many moles of it. Again, you want to include a number, a unit, and a substance in every single part of your dimensional analysis stoichiometry setup problem. And we want to remember that in the mole ratio is the only time you're using the coefficients from your balanced chemical equation. So that very beginning part, when you're going from a quantity to moles, is mole island and everything is per 1 mole, and your end part of the dimensional analysis stoichiometry problem, again going from moles to any one of those quantities, again is going to be per 1 mole. So it's only that middle part, that mole ratio, getting us from substance A to substance B, where we're going to use the coefficients. Remember, your percent yield is actual over theoretical times 100, and that actual yield is basically how much you actually made in the lab, in the experiment, versus your theoretical is theoretically using a stoichiometry calculation, how much should we have gotten. So what are you going to do? You're going to pause the video, and of course you're going to do the problems, but it's up to you. I just show you the solution and the answers all at one time. So you might want to do one by one. You might want to do question 1 and check your answer, then do question 2 and check your answer. Or if you feel confident, do you want to just do all the problems at one time and then check your answers? Either way, obviously, play the video to check your answers, and then I have that quick quiz at the end. So at this point, you either paused already or you're going to pause, and these are the 5 practice problems. Again, to your choosing. Are you going to do number 1 and then check, or are you going to do all of them and check? So I'm not going to do this each time, but I do want you to make sure that you're looking at everything you're supposed to. So number 1, your formulas need to be correct, which means hopefully your balancing is correct. Again, I always put the question mark and unit above the substance I'm interested in, and then all the other information they give us, again, number and unit. Then I did stoichiometry problem twice. In this case, grams of NaCl to moles of AgCl, and grams of silver nitrate to moles of silver chloride. This is where I stopped and paused and I compared my moles. Since my moles here of silver chloride are smaller, then I know that my silver nitrate is my limiting reactant. This is going to limit how much silver chloride I can actually make. Then I did my molar mass of silver chloride to get my answer down here. Then again, I'm going to go back to my problem and go, okay, I actually made 83.93 grams. That's what was given to me in the problem. And theoretically, using stoichiometry like we just did, I'm using theoretically, we should have made 84.27 grams times 100, gives us 99.60% yield. That's very good, right? Because we want our percent yield to be as close to 100 as possible. All right, number 2, the only thing I'm going to mention here is that, again, I compared moles and I did my moles to grams of magnesium oxide here, but the answer is down here. So just know that this answer, I just didn't want to put it all the way up here and make these the font any smaller than I already did. So again, I'm going to use 3 decimal places here again because my mole numbers are less than 1. And since the magnesium here is limiting reactant, I finished the problem, but my answer is here, and then I did my percent yield. All right, number 3, again, give it a pause and check everything over. Number 4, a little different here again because I'm starting at particles. We're starting at molecules here and liters, and we're going to liters. So again, this is kind of spread out, but 4.449 or 5.0 is fine. Doesn't really matter because our oxygen actually is our limiting reactant, only making 3 moles of carbon dioxide, and then I finish the problem going to liters. And your number 5. Again, the answer up here is really down here, just so you know that that's where I just didn't want to extend it out there. So hopefully this is making sense. And again, just as always, I have a quick quiz. So pause the video, do a little bit of work, and see if you can come up with an A, B, C, D answer. Again, that should have taken you some time, but if you did the work correctly, you should get that answer. Again, it might be slightly different because of rounding. Number 2. And again, hopefully this made sense. You've seen this reaction many, many times, right? Hydrogen and oxygen forming water. Again, hopefully you had a balanced equation. You did your stoichiometry problem twice. You found that limiting reactant and then finished the problem to get an answer of B. And again, your number might be slightly different because of rounding. Number 3. So here again is a balanced chemical equation already for you, which is nice because they're nice big numbers here. But hopefully besides doing the limiting reactant problem, you also had to do percent yield, and you should have gotten 94.8, which makes sense, right? Again, you want that good percent yield. You want as close to 100 as possible. All right, guys, that's the end for limiting reactants in chapter 12.